Okay, rolling down the river is a sampling activity that is going to get us used to some of the terms that we will be using for the rest of the statistic unit. We've got convenience samples, simple random samples, stratified random samples, and cluster samples. Now, this activity has to do with a farmer. He lives near a river. His house is over here, and in between his house and the river are his fields of corn. And these tables represent the 100 plots that he has in his field. And in each of these plots, we have the actual amount of corn that was harvested. And we want to go ahead and do a survey or a sample to kind of estimate how much would actually be harvested. So these are from last year's harvest, and we're going to assume that it's about the same as this year. So when we do this, hopefully you've read through this front page to familiarize yourself with the rest of the problem. If not, please pause the video and do so now. Make sure you answer this question. And then on the inside, the next step, you read through, and then you're going to need to fill out this grid here. So we need to number these plots 1 through 100. I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I went across left to right all the way down to 100. So I need to pick 10 plots to harvest. Well, I am going to use a random digit table, which I have attached to this activity on Google Classroom. And I'm going to use, for my example, I'm going to start at line 101. Basically, what I need to do is I need to pick from that table 10 numbers. Okay? And now this gives it to me in single digits. I need to think, how many digits do I need in order to represent my single digits, my 2-digit numbers, as well as my triple-digit number of 100. If I go ahead and make 100 0 0, and I make 1 0 1, 2 0 2, and so on, so that I have 0 1, 0 2, 0 3, 0 4, 0 5, 0 6, 0 7, 0 8, 0 9, and then I have 10 all the way through 99, and then 100 is 0 0, I then represented all 100 numbers as a 2-digit number. This way, I can go through my random digit table, and my first number would be 19. My second number would be 22. My next number would be 39, followed by 50. So I'm going to go ahead and keep doing that all the way across until I get to 10. And as I do it, I'm going to go ahead and highlight each of the numbers that I found. So I've got 19, 22, 39, and 50 already highlighted. These highlights correspond to our sample data from the plots from last year. So I will go ahead and highlight up in the second to last column, second row, right here. The third row, second column, right here. Again, my second to last column, but this time I am 4 down. That was that one. And then I was kitty corner to that one, so this one. These are going to be my data values for my sample. I'm going to use these to calculate my mean yield per plot. So I'm going to add them all up and divide by 10. Then I'm going to go ahead and estimate my total yield. So if I have 100 plots, and I think that on average there's 10 in each, say my mean was 10, I would do 10 times 100 to get 1,000. And my estimated total yield would be 1,000. So you're going to keep doing that for this sample and the other 2 samples. For the stratified random sample, you'll want to number across the top 1 through 10, and you'll want to number down the side 1 through 10. Each of these columns is going to represent a group. They are similar. All of these squares are next to the river. And then we are going to use single digits in our random number generator to pull one number from each column. So say my first one gave me a 6, and My second number was a 2, and then my third number was a 10. I'm going to pick one plot from each group. For the cluster sample, we're going to pick one whole group, but we want the cluster to be exactly alike. So we do that by going across. This way I've got some that are away from the river, some that are close to the river, some that are away, some that are close by. You're going to go ahead again, use these tables to match up your random plot values with here so that you can then calculate your means and your total yield. You also want to go back and estimate what the farmer would have gotten if we used his sample as well.